group.
I don't know which college you go to.
What? Sorry,
Most colleges you don't always have a professor at midnight.
Okay.
But I understand what you're saying.
Hello? Why is this so weird? Okay. You have to do the reset thing. It's okay. It'll be fine. Actually, I'll start there.
Yeah, please. How about an A of X?
Let's plug in. Okay.
For those just joining us, the groups were working this morning
I've never seen that before.
on trying to finish the example that we started yesterday in period 1. Period 6, you didn't quite get there.
Well, period 6 didn't get hard.
No, they just got to see the problem. Here, so let's check the video to clarify questions on homework and get them condensed for today. But then all the groups reached out to Adam and asked if he could help them, so I put him up at the smart board. So we're seeing if he's getting it. Mm-hmm. Just go for it. Then.
I think it's fine. I think it's fine.
Why 0?
Because it's a constant.
Mm-hmm.
Okay, well, I messed up, but like this is
Yeah. But you didn't mess up. Wait, why'd you say
on
mess up?
this.
Oh, got it. Does anybody see a way that Adam could have made his life a little bit easier?
I could have reduced, but whatever.
4 over 16 could be one of them.
Yeah, that's true.
It's like fine.
Yeah, that's fine.
Oh, you should reduce the very
4
beginning.
goes into both, so.
You guys double checking his quotient rule, double checking his plugging in. Do you see what he's doing?
Oh.
He's making the A in terms of just X by plugging in that Y substitution.
I like all this stuff. And then.
What's the last step he would need to do once he has the derivative? Find crits.
Wait.
6,000? All over 3?
Sorry. Wait. The crit of this.
Mm-hmm.
Axes.
Would be 6,000 over 3.
You're right. Oh, equals 2,000. So.
There.
There we go. Good morning. That's all I have to say.
It would be so fun if the video actually did that. You might be a little too quiet, Adam.
That's okay.
You're okay. Okay, so, pause. Somebody else from the beginning of Adam's work. Tell me what he did. I could tell you, but I already knew what to do. Somebody. What's the very first thing Adam did?
He just created.
Okay, we'll use that in a second. So first he
Substituted the y down there into that.
to get area as,
All of this.
yeah, to get area in terms of one variable as a function of 1x. Okay, and then
He distributed the X.
what would have been a little bit more proper for Adam so he doesn't accidentally make a mistake up here when he wrote this, even though it's not incorrect? Yeah, I would put parentheses. Just to be a little bit clear. Technically, PEMDAS would group this division, and so then it would be one quantity that needs the x multiplied to both, but a lot of kids might mess that up. Okay, Mariah, thank you. Kyle, thank you. Somebody else, what happened next? I already got that one. What else? Yeah, derivative. Derivative with the quotient rule, bottom to top minus top to bottom, which any constant will be 0. You could have also, somebody said product rule, just distribute, don't have to do product rule. Quotient rule, just divide, then you don't have to do. Oh, see, I just distribute, or I simplified before what's in my head. It was,
I think it goes in.
yeah, we got it, don't worry. Thank you.
Oh, just.
It's okay, he just fixed it, so we'll just fix it all the way. But he did a quotient rule, and was the quotient rule wrong? No, it was totally fine. But the struggle with the quotient rule is if you get playing with big numbers, you make mistakes. But he was also up to the board, and the smart board orientation was off, and he was a little flustered. But is 4 times 6 24? Yes. And is 4 times 12 48? Yes. And so then Adam wanted to take out a 4 and reduce with a 16. And so that would end up being 6,000 minus 12x. Good? So then why did he write a little x equals down here at the bottom? The crits. We're doing crits, right? Kyrie, can you run up to the library with me? Not with me, for me real fast? And here's your note. Just print that. So then 6,000 minus, or sorry, 6,000 divided by 12, you subtract 6,000 because we're setting the top equal to 0. You have to worry about the bottom equal to 0, guys? No, because 4 doesn't equal 0. That's not going to work. On top, 6,000, we subtract it, divide by a negative 12, we end up with 500, yeah? So are we done? No, we just found a crit. What was the point?
So we can go back and find the rest.
Do we know that this is the maximum area? So way back here, did we ever think about our constraints?
No.
We thought about the $6,000, but that was like its own little equation that we used. We dealt with that constraint, but what constraints didn't we deal with? X and Y, what needs to be true about them as far as intervals? Why am I thinking about an interval? Wyatt, what was that theorem yesterday you brought up?
Extreme.
Extreme value theorem. What does the extreme value for every card say? The function is continuous on a closed interval. All we have to do is test endpoints and crits, and we're good. If the function is either not continuous, or the interval isn't totally closed, or both fail, we have to do function analysis. Sign chart and think about it. So, question. What's my interval for x and y possible values? 0. Is that open or closed, though, to make an actual realistic plot of land fencing? Has to be open, right? Can you have a width of 1/2? Sure, it'd be a really weird field that nobody ever wants, but yeah, sure, why not? But can you have a width of 0? Nope, there's no field. How big can x and y be? How on earth is Adam figuring out that x and y have different constraints? That x and y both are minimized by 0 as variables. But why is he saying 2,000 for x and 3,000 for y? The price is, yeah, I only have $6,000 bucks. So if I were to spend all my money on the x fencing, wait a minute. If I were to spend all my money on the x fencing is which one again? You can tell that from our equation, right? The $3 one. I have $6,000 bucks and I have 2 different x sides. So let's just say y was 0, which is impossible. This is impossible also. But if we spent all our money on the x fencing and then ran out and went, whoa, and then we kind of failed at life, we would have 2 x's that we were buying for. So 6,000 divided by 2 is 3,000. Divided by 3 is, oh, actually, x can only be 1,000 because I have to make 2 x sides. And then what if I spend all my money on my y fencing and I run out of money and I didn't realize what I was doing? Well then, 6,000 divided by 2 of the y's would be 3,000 divided by 2 would be 1,500. Anyway, long story short, do we have closed intervals?
No.
Oh, so does it really matter the intervals? Are we even testing endpoints? No. So instead, all we have to do is a quick function analysis. And a quick function analysis says, do we already have a derivative? Yes or no? Yes, if we already have a derivative, it shouldn't be too bad. All we got to think about is a prime. And the nice thing about a is he's only dependent on x. So hold on. X can only go down to 0 and only go up to 1,000, which would have told us that the other, what did we have? 6,000 divided by 3, right? 2,000. It didn't make sense. We wouldn't have enough money to even buy that much. Does that make sense? My critical number of 500 does make sense. And all I have to do is do a quick little like, hey, if I plugged in 100 to this, 1,200, I'm totally fine. And if I plug in like 900, that's like 10,000 something. Question. If the function is strictly increasing and strictly decreasing, where is the absolute maximum going to be? We got it. We got what? We got the x measurement. Wait a minute, what was the point of the problem? Did you guys write it down? It said, what are the dimensions? Oh, it doesn't just want x. That's okay, I've got it. The dimensions of my field are going to be 500. Did anybody write down, is it feet?
Yeah.
By, what's the relationship between x and y? Adam had to substitute. He got rid of y by plugging in, what's y equal? It's right there in your work. 6,000 minus 3,000 is 3,000. 3,000 over 4, it's a little bit awkward. It's going to be what? 1,500 over 2, which is going to be 750? Someone double check me. I might be off. 3,000 over 4, 750? Perfect.
You have to divide by 500.
No, because x was our variable, and our variable is one of the lengths of the side.
So if there's two 500s, then you've got like 1,000 x's and 3,000. Oh,
no, not 1,000 x's. You see it?
Yeah.
Because I made the formula being 2 of those x's and 2 of those y's. I've already accounted for the 2. Yeah, good. Okay. I'm going to give you guys another example, just because I want you to kind of maximize on what we just did. But this time, I'm not going to make you just go from scratch. Well, we went from scratch yesterday. I'm going to kind of give you some clues and some hints.
I didn't realize your hood was D. I like it.
Oh, my elf had a little elf ears. Anyway, I'm not going to put it on. Not right now. It was my ugly Christmas sweater for my small group last year. Okay, I want you guys to read the following problem. Read the following problem.
Oh, I hate these.
And I want you to throw this in that nice little page protector. Because you guys are going to use it, and 36 is going to use it. If this is the outline for basically any optimization problem, remember related rates had an outline?
Yeah.
I want you to be thinking as a group, what would you fill in to each category? I actually made it even easier. So read the problem and think about, without a marker, without writing anything down. Without a marker, without writing anything down. After reading the problem, what do you think you would fill in each of these spots?
First number. Okay.
X and Y.
Yeah, but you put it in
Find the two other numbers. No.
The sum of the first number and 20. Yeah.
Okay, so X plus 2Y.
The product is multiplication. Inside the center.
Choose one, so it could be R. I think actually these are
Let me see the
We're on the
equation with the
primary equation or the one there's
so there is a variable we need to match.
So you see that.
So that's not.
How many groups do we have? Just 5, right?
1, 2, 3,
So there's
S-U-G-A-R. Add a little
Okay,
bit
so
more.
X, what?
Where's Abby?
Her 10-minute thing didn't work
She's
so well.
coming.
And?
You told her she was at school this morning.
No, I said she's gonna be at 10 minutes so that you can text me, but she's like 20 now.
More 30.
That's okay.
Oh, who's-
Gail. Who's counting?
Okay,
I'm
And
counting.
then.
ready? I want one person for every group to come up to the front table in 30 seconds. I want you to get one clue from every pile. See if I get it. Where are we at? 2 seconds?
You get one clue.
One clue
Per
from every
pile.
pile.
Every pile.
And I want you to put it in the correct category. And
I like
then
this. This is nice.
I want you to go ahead and finish the problem like you just did. Ready, set? One person from every group, come on up and grab one from the pile. Very first group, I have them all for you. Alright. Put them in the right category and then finish the problem.
Are we right?
Yeah, white.
Okay.
One from every category.
We'll have to see.
And finish the problem. Get them in the right order. What would you put where?
Yes.
And once you have it in your notes, finish.
And so I can teach them how to
Yeah, we
do
can.
After that, application, whatever's inside.
Oh.
Yeah, I only have 2.
Wait.
Yes, and that's a
Uh-oh.
secondary.
Guys, do you have one of each? Probably just way more than one.
You, Maya.
How many should I have?
1, 2, 3, 4. You should have 4.
Because this is
3 or 4.
like this and she's
I have 3.
Oh, Wyatt.
5. You should have 5.
Oh, 5.
Oh, we have 3.
You have 3. Somebody's gonna find 2 actually somewhere. He might be getting it. He's getting it.
Oh, yeah,
Where does everything
Maya.
go? And once you have it, and your group is in agreement, in your notes, finish the problem.
Wait, is it supposed to be 6?
I didn't finish the problem. Not everything has it filled in.
Oh.
not everything has to
So
fill
this
in.
is the expression.
This is just like.
No, just so it said define the variable. So we have to find the find.
Which one's the fine? Just a hint, the very bottom one, I did not give you anything for.
Okay.
The very bottom one, that's you doing the math.
This is fine. This is
Oh,
Are you
fine?
fine? Yes.
Fine is math problem.
Yes. This is like a video because
Dude, I was such a terrible student. I
This one?
dude.
Space for a picture, but we don't have to have a picture.
I bought it.
I set it up, you guys have to finish it in your notes.
Oh, shoot.
I don't know what you want.
Dude, what a cheat. It is already out. You're right.
Yes, now finish. Let me see, where'd you put everything? Yes, now finish.
And we know our mistakes.
Yes. You realize that's the end, right?
What do you say?
That makes sense.
Identify variables.
Alright, finish the problem. Is that a kind of nice way of organizing the information though, as far as like, hey, identify the variables, what are the constraints? Because we forgot the constraints for. I left space for a picture, but did this one need a picture?
No.
Oh, okay. Well then, never mind.
No. Even if you
My body is like last year I did
A couple things you guys should be thinking about. Did you beat me?
Nope.
Did you figure out everything? Then did you figure out most things?
No.
But now in hindsight, do you think you could do it if I asked you something very similar?
Distribute. I have mom. I have mom. You great. Boom.
That's one of the most
Oh, Miss
satisfying.
T, you found an easier way.
You derived it.
Well, I was doing it fast. These ones will be the nice ones that I keep. You guys have it the scratch version. What are you guys supposed to be doing? What are you working on?
Derivatives.
Analyzing, which will need a derivative, right?
Yeah.
Do we have open intervals or closed intervals?
Open.
So if it's open, are we allowed just to test the endpoints? No, we need to analyze with a sign chart, yeah?
Wait, but if it tells us the product,
What do you mean, Matt?
well, because it says in the product is a.
No, I don't want to.
No, that's what you're trying to find.
Okay.
You're maximizing the product.
Oh.
You see it? So it's not saying the critical number will be a max, it's just saying what is the max, and you're saying, oh, calculus says find critical number.
So it's only the memory.
I just need 5, so I got, originally got 216.
All right.
Why are you analyzing? Because if the AP said something like justify or explain, you couldn't just say like, it's a critical number. That's not enough. That only means it's a possible triple. Where's Sherman?
Oh, I got. Oh, okay. Stop it.
Yay!
They gave me my card at the back.
You can join the first group.
How are you doing, Abby?
Better.
What's 108?
216.
Should we reduce? Reduce the floor?
Yeah, that's multiplied to 0. And that's
And then reduce.
This is that. Oh,
Yeah, first goal.
You can ask Adam.
Whatever.
I'm gonna say.
For those that are joining us, or for those at home, each of the groups were given the following outline of how to process basically any optimization problem. And then they were given little snippets of answers they were supposed to arrange in the correct order. And if they did them correctly, the variables, they could have named it whatever they wanted to. I happen to name it X and Y. I'm going to go and make my marker a little bit thinner. This is going to be a mess.
90.
There was something that told them 2 numbers. And because, wait a minute, did anybody figure out why both X and Y need to be between 0 to infinity? How did I know that? Positive. Yeah. Has to be positive. Defined was the maximum who? Products, and I named the product also. So technically, if I had left more space, I would have named the other variable too, the other variable also. But I just named it down here. I was like, okay, fine, he's P for product. Because then over here for my, I didn't need a picture, so we didn't worry about that. But for my primary, I said product is, well, product means times, right? Oh, that's not a big deal. X times Y. But then was there another clue? And the answer was?
Yeah.
The sum of that. But do you guys see how this took up the majority of the problem?
Yeah.
Isn't that going to be a little bit confusing if the majority of the problem isn't the actual main point? It's a constraint. It's important. We have to use it. I'm going to call it my better store it away, better use it, and we have a place for it right here, secondary. But the sum of the first number and twice the second number is 108. Now, question. You guys got to enjoy there being a nice little one last clue that hopefully you put in this category. But my question is, where did it come from? It was a CalcAB jump. It's not magic, it's math. Where did it come from?
Subtracting x and divided by 2.
So up here, solving for, I can do it, right? Solving for y would have you subtract the x and divide the 2. And just like Adam did to start off his problem today on the board helping you guys out, where does this go and get plugged in? To get the product in terms of one variable. Because we want it in terms of one variable in order to analyze, right? Now, hold on. Use what Adam did. Hopefully you guys did. Should you take a derivative right now? Product and quotient rule.
No.
So, how's the way to simplify things a little bit? Distribute. What do you guys want to do? Just distribute and do a quotient rule, or distribute and divide and not have to do either?
Distribute.
Okay. So 108x minus x squared all over 2. And when you take a derivative, because that's our first step in analyzing, is finding our critical numbers, we end up with bottom d top, which would be 108 minus 2x, all over 4. Now you guys could make it harder, or you could make it easier. Why not just simplify right now and say, you don't matter, right? You could go more and factor out, but most of you right now are like, whatever, I have something that's equal to 0, I'll just do that. That doesn't matter, there's no DNEs. Subtracting 108 and dividing by 2, we end up with x is equal to?
54.
54. But what were they asking for in the very beginning of the problem?
2.
But hold on, so I just find the y and I'm done and I hope that I'm right?
No.
I have not proven a thing. All I've found is a critical number. But pause, how do I analyze? Oh, critical numbers and n! I don't have endpoints.
So just the critical
So
number.
just the critical number in a side chart. Wait a minute, but I'm not going to go from negative infinity to infinity because this one had to start at 0. So I was talking about positive numbers. Oh, well, I guess that one goes on forever.
You can write it.
I could write infinity, but that's kind of weird. I have my 54. Plug in something. Oh, 54. Plug in something like a
50.
1.
Oh.
Where am I plugging it in?
That's P prime.
Plugging in 1. Oh, that's definitely a positive. And plugging in whatever, that's definitely a negative. Could I write a paragraph explaining why this is the absolute max?
Exactly.
Yeah.
Why is it the absolute max? What's the function doing? The function from forever is increasing and from forever is decreasing, right? Yeah, so it's going to be the absolute max. Well, it's only a relative extrema according to the sign chart, unless I realize it's strictly going up and it's strictly going down. That has to be that. Because if it was going up and going down and coming back up, couldn't it go higher than that? So I'd have to be careful.
Relatively, yes.
Absolutely.
No.
Oh. So therefore, now I can say I could do a defense if I needed to, but I know for sure, that's the absolute max. And so therefore, I have my two numbers of 54 and, wait, where'd you guys go to find the other one? We wanted both. Do you realize this little substitution you do? Do you revisit? And you go ahead and plug in, and what'd you guys get?
27.
Dun, dun.
You did it. We did it.
Now, I want you guys to take all those little baby papers and just tuck them in the back of the little paper projector. So not so it's, I mean, I guess you could do it in the front. Why not do it in the back? So not like where the words are, but on the back side. Just slide them in. Make sure they go all the way to the bottom. I'm going to come around and get them in a second. But question, is this guideline helpful?
Yes.
Yeah, I think so too. So keep it at your desk. I'm going to give you another problem. Ready, set? In your notes, though. If you want to get a marker and write on it, you can. But I don't mind if you just go straight to your notes. What if I have you analyze A cylindrical means a cylinder, yes.
Cylindrical?
Are you drawing a picture for this one?
Yeah.
Yes. And if
What's
I
the
were you,
Like a
should you start with the variables or start with the picture and think about what variables are in the picture?
Picture
So,
variable.
You might bounce around a little bit and might not always go from the very first step to the very last step. Maybe draw a picture first.
Do you have the?
Wow. We probably do this.
Because you're thinking about a manufacturing plant, kind of, right?
Do you have the equations?
Tom said it yesterday.
Well, the volume formula of anything is area of the base times the height, and cylinders have what kind of shapes in the base?
Circle.
And what's the area of a circle from your
Pi r squared.
And then just times the
I
V equals pi r squared height.
H.
Wonder which equation that is. Primary or secondary?
I'm gonna say primary.
Never just make a guess. You might be right, but I need to know why. Ooh, just wait until second semester. I went to a really cool workshop at that math conference. It's called How to Use Debating in Math. You can never just give an answer, have to have an answer and a difference. That can get fun.
Is it we have a bunch of instruments in that class, Steve. Is it gonna get fun?
It says it holds 500 cubic centimeters.
0 to.
We know that the equation will equal.
What are we gonna do in class after?
Watch movies and eat.
We don't really have as much time as you would think.
Cause ours is second week, right? Steve?
Yeah.
Yeah.
I feel like once you get past May 15th and you're not all APs, you can
M3. So hopefully Mr. Hanson doesn't do anything. Hopefully Mr. doesn't
I
do
think I'm
anything.
gonna do.
Hopefully.
But if he does, it's probably going to be interesting, and it's probably going to teach you some habits.
Probably.
I love Canton.
Captain was like,
Hampton!
how are you?
Yeah. She's right there, John.
Yeah.
Oh, you guys heard how I cut new ones. Sorry, can you take those old little scratch pieces of paper out? Because I cut nicer ones. Sorry. We'll switch. My bad.
Sorry, Mariah.
Raining. Wow. What? You didn't want to go yesterday. What am I talking about, Steve?
Why did I say gotta go?
Oh, I think she's dealing with it.
Some of you should be asking me how to find the surface area of a cylinder. Do you realize it?
I was just a joke.
Wait. Oh, we were finding something.
But I actually did check out.
You should be asking me how to find the surface area of a cylinder. And you should be thinking about how circles are on top and on bottom, and if you cut a can and opened it, it would be a rectangle.
Wait.
You should be thinking how there are circles on top and bottom.
Wait.
And if you were to cut a can or a soup label and unfold it, it is really a rectangle.
Are we opening the whole? If it's open at the top, do you need one or two?
Wait, if we have wraps around.
So how many circles do we have if it's open at the top?
My head hurts.
So let me know.
SMH my head, bro.
SMH my head.
Ready for me to start filling stuff in?
Yeah.
I'm trying, I thought I could get it, but then I realized.
Volume.
I realized I'm height.
Volume is the easy formula. But sadly, it's the secondary clue.
The circumference is the. That makes sense.
Dad's just looking at it, she's like, what are you talking
You know,
about?
like a rectangle, the height. Yeah, the height. And then the circumference of the top is going to be the.
Alright, here we go.
Yeah.
This will be our last example.
Wait, what's circumference?
Alright, sure.
No.
2 pi r or pi times b?
Oh my gosh. 2 pi r. Oh my gosh.
Did you hear me say it?
I said,
Times what?
So what happens if the radius?
Whatever. That's what we're trying to do. You don't know yet.
That was the clue.
Yeah.
Because, what was the find?
R.
Height and radius.
Why surface area? Volume is what goes inside. Surface is what's on the material to make the can. That's surface area as far as a mathematical dimension. What are my variables? Okay, we already have S as surface area, so then don't we just have, well, do you guys want to use R and H, or do you want to use X and Y? I don't care.
R and H.
R and H. Okay, so we have my R being my radius, my H being my height. Constraints, both R and H can't be 0, right? Just practically speaking. So am I going to have an open interval? Yes. So basically, do I really even need to keep going? I don't have endpoints, right? But just to be safe, it does say that it holds 500. So question, if R was 0, well, it can't be 0. Okay, well, if R was 1/2, what would H be? Something big. But couldn't R be 1/4? Even bigger. Couldn't R be 1/8? Even bigger. Couldn't R be 1/100th? Even bigger. Oh, stink. I guess technically it'd be really weird cans that at some point would not be practical in any common use. But technically, I guess we could keep on mathematically making this guy smaller, 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 and him bigger, bigger, bigger. But we're still missing our primary. Kathleen.
Oh, wait, is the surface area apart from like the part where it says manufactured can?
Amount of material.
Are they trying to like find a circle?
Well, is the base going to be a part of the can? Yeah. So when I go to make my surface area, I am going to need to go ahead and have one base, but Adam said it's open on top, so there's only one circle, but then I also have the can on the outside. But think, if you have a piece of paper, can't you like twirl it and tape it and you have a cylinder? Well, I'll put a circle on the bottom. So all I need is a rectangular area where the height is h, that's easy, and the base is the circumference. Because the circumference, when I cut it and unravel it, is how long it is. So that's why Adam was saying 2 pi r. Because this is equal to a rectangle of an h and a 2 pi r plus a circle.
I have a question. Are we? Oh yeah, we're adding. Because in the S, there's no add.
I don't know about you guys, but I don't like H. I don't know, he just looks complicated, so I'm getting rid of him. Because I have to get rid of someone, right? So then can't I have my S being in terms of R, that's the guy that I'm choosing. I'm going to have 2 pi squared r cubed times. Do you think we should go taking derivatives right now, or do you think we should maybe rewrite it to make things a little bit easier first? Don't you have some nice substitutions and, sorry, some nice reducings to be? Yeah.
Aren't we just adding the pi r squared?
Oh, yeah, that's my bad. I was talking too much. But guys, you know where we're headed, right? Because we're trying to find S prime, or we're trying to analyze. What did Adam say? Sorry, it's plus. I put it times. That's going to mess it up. Alright, I'll see you guys later. Alpha's coming in, which means I can't really take extra time, because if they don't have me on my game ready to stare them down and do algebra, I'm going to lose in the class. So, you guys keep going. Give me your little paper protectors on the way out, my leaders of the group, or my people of the group that are holding on to it. Bye, everybody.